Hi friends, welcome to the fourth part of module 5. Today we will be continuing with plane motion of rigid body. We have already discussed what all are the theories, concepts and formulas related to plane motion of rigid body. So before starting this part, just go through the previous video lecture. The link of that video will be given in the description box. So there itself we told that there are two examples which we will be discussing in plane motion of rigid body. First case is motion of roller without slipping. We have done some problems also related to that. We will be doing some more problems in this part. And also the second example is the motion of a bar which is kept on a floor at one end and wall at the other end. So we will be doing that problem in this part. So this was the page in which we discussed about the concepts related to motion of rollers. We are not discussing it again. If you have any doubt, just refer the previous part, understand the concepts, and after that only start doing the problems. Okay, the first problem is a cylindrical roller is in contact at its top and bottom with two conveyor belts AB and DE as shown in figure. If the belts run at uniform speeds of 3 meter per second and 2 meter per second respectively, find the linear velocity and angular velocity of the roller when. There are two parts. First one, the velocities are in same direction. Second part, the direction of velocities are opposite. The diameter of the roller is 40 centimeter. So this figure is given in the question itself. There is a roller. There are two conveyor belts AB and DE. P is the midpoint of AB. Q is the midpoint of DE. C is the center point. So let us see the first part. If the velocities are in same direction. So we have drawn this figure again. So this is the conveyor belt AB, P is the midpoint, Q is the midpoint of DE. Now center point is C, so velocity of C is given as VC. All these are moving towards right, which means the roller is moving like this, towards right. Now if the velocities are in same direction, which means it is given in the question that the belts run at uniform speeds of 3 meter per second and 2 meter per second. Assume that the top belt is 3 meter per second and the bottom belt is 2 meter per second and both are in the same direction. So as this is the P is the midpoint, we can write Vp, velocity of P equal to 3 meter per second and velocity of Q equal to 2 meter per second. Now in the previous problems we have seen that all those things were given in terms of the center point, that is velocity of C is given. We have been asked to find the velocity of the end points. Here it is the opposite. The end velocities are given. We have been asked to find the velocity of the center point. Find the linear velocity and angular velocity of the roller, which means to find the velocity and the angular velocity of the center point. How to find that? The same equation itself. Velocity of P, vector addition equal to velocity of C plus velocity of P with respect to C. Now what is velocity of P with respect to C? It will be PC into omega. So what is PC? It is the radius. The diameter is given as 40 centimeter, which means it is 0.4 meter. So PC is the radius, which is 0.2 meter. So velocity of PC is 0.2 omega. Now, how to find velocity of P? It is velocity of C plus velocity of P with respect to C. Both are in the same direction. So just add it. Velocity of P is given as 3. So it is 3 equal to velocity of C plus 0.2 omega. VC and omega is unknown. Let it be equation 1. Similarly, for the point Q, it is velocity of Q, vector addition of Q, velocity of Q equal to Vc plus velocity of Q with respect to C. Now, how to find velocity of Q with respect to C? It is Qc into omega, which is again, Qc is the radius, which is 0.2 into omega. Now, we can see that velocity of Q equal to, this is velocity of C is towards right, velocity of Q with respect to C is towards left. So we will be subtracting it. So velocity of Q equal to velocity of C minus velocity of VQC, which is 0.2 omega. So you will be getting velocity of Q is 2. So it is 2 equal to Vc minus 0.2 omega. This is equation 2. Now solving equation 1 and equation 2, we will be getting velocity of C as 2.5 meter per second. Substitute Vc in equation either 1 or 2 and we will be getting omega, angular velocity. So this has been asked in the question to find the linear velocity as well as angular velocity. Now the second part is if this 3 meter per second and 2 meter per second is in the opposite direction. So assume that 3 is towards right and 2 is towards left. So in one direction it will be taken as positive, and in the other direction it is taken as negative. Let in the right direction it is taken as positive, and in the left direction it is taken as negative. So Vp equal to 3 meter per second and Vq equal to minus 2 meter per second. Now the remaining things are similar to what we had done in the previous part. So velocity of P equal to velocity of C plus velocity of P with respect to C. Initially we will be calculating velocity of P with respect to C, which is Pc into omega. All those things are previous things itself. Pc is 0.2 into omega. Now this velocity of Pc and velocity of C is in the same direction. So velocity of P will be just addition of this one, velocity of C plus velocity of Pc. So you will be getting equation 3. Now the next thing, similarly for velocity of Q, it is vector addition is velocity of Q equal to velocity of C plus velocity of Q with respect to C. So velocity of Q is, the direction is opposite, which means Vc minus VQC. How to find VQC? It is QC into omega. VQC is QC into omega, which is 0.2 omega itself. And also this VQ is minus 2. Since it is moving towards left, it is minus 2. So minus 2 equal to Vc minus 0.2 omega. This is equation 4. Solving equation 3 and equation 4, you will be getting velocity of the center point C. And substituting this either in equation 3 or equation 4, we will be getting the angular velocity omega, which is 12.5 radians per second. Next question. A car is moving with a velocity of 20 meter per second. The diameter of the wheel is 100 centimeter. The wheel is running on straight line without slipping. Find the velocity of the point at 60 degree in the clockwise direction from the top at any instant. So here it is given that a car is moving with a velocity of 20 meter per second. Figure is not given, so we have to draw the figure. So there is a car, this is a wheel, center point is C. The car is moving with a velocity of 20 meter per second, means it is the center point. Center, with respect to center point we are saying. So velocity of C equal to 20 meter per second. Now the diameter of wheel is 100 centimeter. Find the velocity of point at 60 degree in the clockwise direction from the top at any instant. At any instant we have to find the velocity of this point. Let the point be P. So we know that if there is a point P, if there is a point C, if we are connecting this PC, then velocity of P with respect to C will be perpendicular to this PC. So it is perpendicular to this PC, and this velocity of PC is making an angle of 60 degree in the clockwise direction from the top. So if you are drawing a line like this, it is making an angle of 60 degree. So velocity of PC is making an angle 60 degree. Now we have to solve for the velocity of P. So as in the previous case itself, we are doing it. What all things are given? Velocity of C is given 20 meter per second. So we have the equation velocity of C equal to R into omega. So omega equal to this Vc is known to you, R is also known to you. So omega equal to 40 radians per second. Now how to calculate the velocity of point P? It is with respect to center, velocity C plus velocity of P with respect to C. This is vector addition only. So Vc plus velocity of P with respect to C. Now what is velocity of P with respect to C? It is Pc into omega. Pc is known to you, it is radius 0.5. Omega is, you already got it as 40. So velocity of P with respect to C is 20 meter per second. Now we have seen that in the previous problems it was to find the velocity at the top point, bottom point, leftmost point, rightmost point, etc. We haven't seen anything like this, which is inclined, but in the concept page we have already discussed how to do this one if it is inclined. So this is a simplified figure. This is the velocity of PC. What we do if it is inclined is we will be resolving x direction as well as in y direction. So if velocity of PC is resolved in x direction, this is 60 degree, so it will be velocity of PC cos 60, and in y direction it will be velocity of PC sin 60. Now to find the velocity of P, we will be finding in x direction as well as in y direction. So velocity of P in x direction equal to, what all are the velocities in x direction? It is velocity of PC cos 60, and there is velocity of C also. We will be considering that C velocity also. So this is also moving towards right, same direction. So it is just addition. So it is Vc plus Vpc cos 60. Vc is known to you. Vpc value also you got. You will be getting velocity of p in x direction as 30 meter per second. Similarly, what is the velocity of p in y direction? This is velocity of pc into sine 60. So you will be getting it as 17.32. So again, simplified form is this one. Velocity of p in x direction is 30 meter per second. Velocity of p in y direction is 17.32. Now, how to find the resultant? Resultant is velocity of p, what we require. So velocity of p equal to resultant of these two values, which is resultant of which is equal to root 30 square plus 17.32 square. So you will be getting it as 34.64 meter per second. And if you are asked to find theta value, we will be finding by tan theta. Tan theta is opposite side, which is 17.32 divided by adjacent side 30. So from that you will be getting theta equal to 30 degree. So these were the problems related to motion of roller without slipping. Now the next is motion of a bar which is kept at floor at one end and the wall at the other end. So let us see the problem. A bar PQ of length 1 meter has its ends P and Q constrained to move horizontally and vertically as shown in figure. The end P moves with constant velocity of 5 meter per second horizontally. Find the velocity of the end Q. Second one, the angular velocity of the bar. Third one, the velocity of the midpoint M. So this is the figure which is given in the question itself. There is a bar PQ. The point on the floor is P, on the wall it is Q. This is at P point, it is moving horizontally 5 meter per second, and Q it is moving vertically downwards. So we know how a bar can be done as a combined motion of translation and rotation. Initially this is moving in a translatory motion, and about this point Q it is rotating. So it is a combined motion of translation as well as rotation. We have explained it in the theory part. So please go through it again, how it is a combined motion of translation and rotation. About this point, it is rotation. It is rotating after translating. So in the previous problems on the rollers, we have seen it was with respect to the center point C. So instead of that C point, it is with respect to the point P, which means about which point it is rotating. We are seeing that in this case for the bars, about this point P it is rotating after being translated. So everything will be with respect to this point P itself. Now let us see, this is a figure. So velocity of P is towards right, velocity of Q is downwards. Now what will be the velocity of Q with respect to P? What will be the direction? This velocity of QP will be perpendicular to this QP. Velocity of QP perpendicular to the line QP. So what we want is, we want to know what is the inclination of this velocity of QP with respect to the horizontal. In order to solve that, we know this angle is 30 degree. This is given in the question itself. If this is 30 degree, this is perpendicular 90 degree, so the remaining will be 60 degree. Again, this velocity of QP and the line QP is perpendicular. So if this is 60 degree, the remaining will be 30 degree. Also we know that this horizontal and vertical is 90 degree. So if this is 30 degree, this will be 60 degree, which means the velocity QP is inclined at 60 degree with respect to horizontal. So in order to make it again simpler, we will be drawing it by a vector diagram. In many texts, they have done in different ways. So I think this will be simpler by drawing vector diagram, which means we will be drawing all the velocities over here and the directions also. So velocity of PC is towards right, so it is shown like this. Velocity of Q is downwards. Now velocity of QP is, this is velocity of QP, which makes an angle 60 degree. Velocity of QP makes an angle 60 degree. So this is the vector diagram in which all the velocities are shown. Velocity of P, velocity of Q, and velocity of QP. Now from this vector diagram, we will be solving the remaining things. So let us see the first one. To find the velocity of the end Q, which means to find this VQ. From this triangle itself, we can solve it. If it is tan 60, it is opposite side VQ divided by adjacent side VP. So VQ equal to VP into tan 60. VP value is already known to you, which is 5 meter per second. So from that, you will be getting velocity of Q, which is 8.66 meter per second. Now the second is to find the angular velocity of the bar. angular velocity omega. So how to find the angular velocity? We have seen it like velocity of qp equal to qp into omega. So that omega is to be found out. So to find that, take sine 60 from this vector diagram. Sine 60 is opposite side VQ divided by hypotenuse VQP. Again, VQ is known to you. Sine 60 is okay. So from that you will be getting velocity of QP, which is 10 meter per second. Now again, velocity of QP is QP into omega. So velocity of QP is known to you. You already got it. QP distance is also known to you, which is 1 meter. So from that you will be getting the angular velocity omega, which is 10 radians per second. Now there is one more part in this question, the velocity of the midpoint M. So how to find that? Velocity of the midpoint M means it is with respect to this P itself. So velocity of M vector addition is velocity of P plus velocity of M with respect to P. Now what is velocity of M with respect to P? It is MP into omega. What is this MP? This is midpoint of PQ, which means PQ is 1 meter. So MP is 0.5. So it is 0.5 into omega value. You already got it as 10 radians per second. So velocity of MP is 5 meter per second. Now this has been simplified like this. Velocity of PC is towards right. Velocity of MP. Now what is this angle? How to find the velocity of angle of velocity of MP? So we know that this velocity of MP and MP is perpendicular. This is perpendicular. This angle is 30 degree, which means horizontal, and the bar is 30 degree again. So this horizontal line and bar is 30 degree. This is 30 degree. And we know this QM is perpendicular to velocity of MP. So the remaining is 60 degree, which means this velocity of MP is making an angle 60 degree with horizontal. Now this is just similar to the previous problem what we have seen in rollers. That is, if a velocity is inclined, how to solve it? So we will be resolving in x direction as well as in y direction. So if it is resolved in x direction, it is velocity of MP into cos 60. It is towards left. And in the y direction, it is velocity of MP into sin 60 acting downwards. So velocity of M in x direction will be equal to, we will be considering this P also. So velocity of P towards right taken as positive minus this velocity of MP cos 60 is towards left. So it is taken as negative. So it is the value is 2.5 meter per second. Now similarly, velocity of M in y direction is this one acting downwards. After resolving in y direction, it is velocity of MP into sin 60. So you will be getting 4.33 meter per second. So this is velocity of M in x direction and velocity of M in y direction. How to find the velocity of M? It is the resultant of these two values, which is root of Vmx square plus Vmy square. You will be getting 5 meter per second. Here the resolution is not shown over this figure. So if you have any doubt, just refer the previous problem. We have shown it in detail. The same thing will be applied over here also. Okay, let us see the last problem. This is a very important problem. This has been a regular question in the previous KTU question papers. So let us see the problem. In the reciprocating engine mechanism shown in figure, the crank OA rotates at a uniform speed of 300 rpm in anti-clockwise direction. The length of crank and connecting rod are 12 cm and 50 cm respectively. Find, first part, the angular velocity of the connecting rod AB. Second part, the velocity of piston when the crank makes an angle of 30 degree with horizontal or inner dead center. So this is a problem with respect to reciprocating engine mechanism. In some questions, they will be giving the figure. In some questions, they won't give the figure. Anyway, here the figure is given. So let us see it carefully, how the figure is. In a reciprocating engine mechanism, there are some parts like there is a circle. This is the crank. There is a crank in it. Then there is a connecting rod and there is a piston. So we already know, we have studied it in your mechanical. So if this piston is moving forward, this will be moving in the anti-clockwise direction, and if this piston is moving backwards, this will be moving in the clockwise direction. So the same thing is being applied over here also. we should understand the direction of motion, and at that same time we should understand what will be the direction of these connecting rods. So there are three parts in it. First one is the crank, second one connecting rod which is connecting this crank and piston, and the third one is piston. So for these three parts we should understand the direction of motion. So in this case, it is given in the question that it is in the anti-clockwise direction, which means in the anti-clockwise direction means this piston is moving in the forward direction, which means it is moving towards left. Then only this crank will be moving in the anti-clockwise direction. So it may in some questions it may be clockwise direction, and in some question nothing may be specified. So if nothing is specified, you can either solve it as clockwise or anti-clockwise direction. So anyway, here it is anti-clockwise direction, which means this piston is moving forward. If this piston is moving forward towards left, what is the velocity of this B point? If this is moving towards left, velocity of B also will be in the horizontal direction and it will be towards left. Now what will be the velocity of this crank OA? This is moving towards left, which means this OA will be moving in this direction, which means the velocity at this point A will be in the upward direction. Similarly, what will be the velocity of this connecting rod? As this is moving towards left, the velocity of B with respect to A will be perpendicular to BA, and it will be in the downward direction. So if it is in the anti-clockwise direction, we should understand what is the direction of motion. So velocity of B will be towards left, velocity of A will be in the upward direction and it will be perpendicular to A. Velocity of B with respect to A will be in the downward direction and it will be perpendicular to BA. Now let us see each one individually. So first one, consider the motion of crank OA. Now for crank OA, it has been given in the question that it rotates at a uniform speed of 300 rpm, that is rpm rotations per minute. Now what is the relation between omega and rpm? Omega equal to 2 pi n by 60, where n is 300. So you will be getting omega equal to 31.4 radians per second. And also it is given in the question that this crank OA is 12 centimeter, which means it is 0.12 meter, and the connecting rod, which means AB, is 50 centimeter, which means it is 0.5 meter. Now what is this velocity of A? Velocity of A is given by R omega. Here R means it is OA into omega. So OA is 0.12 into omega, it is 31.4. So you got VA as 3.77 meter per second, and this VA will be perpendicular to OA. So we have drawn it separately over here. So this is OA and VA is perpendicular to OA. But what we want is this velocity of A with respect to the horizontal inclination. So what will be that? We know this angle is 30 degree. It is given in the question itself. So if this is 30 degree, if you draw a horizontal line here, this is also 30 degree. Now OA and VA is 90 degree, which means this angle is 60 degree. Or in other way, we can say that this VA is inclined at 60 degree with respect to horizontal. So this VA is 60 degree with respect to horizontal. Now consider the motion of connecting rod AB. We want this angle phi. Let this angle be phi. So we want to calculate this phi. How to calculate it? We know this distance OA, this AB distance is also known to you. This angle is known to you. So in order to calculate phi, using sine rule we can do it, which is OA divided by sine phi equal to AB divided by sine 30. So OA divided by sine phi equal to AB divided by sine 30. OA distance is 0.12, AB distance is 0.5. So from that you will be getting sine phi and as well as phi, which is 6.89 degree. So this phi is 6.89 degree. Now if you are drawing it separately, this is the connecting rod AB. Velocity of BA, as we told earlier, it will be downwards and it is making an angle 90 degree with respect to AB. Now what we want is the velocity AB with respect to horizontal. What is the inclination? So velocity BA with respect to horizontal, the inclination will be this angle is phi and this is 90 degree. BA is perpendicular to velocity of BA. So the remaining will be 90 minus phi, which is 90 minus 6.89, which is 83.11. Or we can say that velocity of BA is inclined at 83.11 degree with respect to horizontal. Now again, we are drawing the vector diagram. So we have seen that velocity of A is inclined at 60 degree, velocity of B is towards left, and velocity of BA is inclined at 83.11 degree. Now using sine rule means side divided by sine of angle between the other two forces. So this theta and this angle is unknown to us. So let us solve it. This 60 degree is already known to us. If this is 83.11 degree, this is also 83.11 degree. And let this angle be theta. Now how to find this angle theta? This is a triangle. So theta will be equal to 180 minus 60 minus 83.11. So you will be getting theta equal to 36.89 degree. Now what we want is to find the velocities of other points, which is unknown. The angles are known to you. Some of the velocities are known to you. So by solving this diagram, we can find it, which means using sine rule we can solve it. So it is VA divided by sine 83.11 equal to VB divided by sine theta equal to VBA divided by sine 60. So it is like this. From this, VA value is already known to you. We have already solved it, which is 3.77. So taking each one at a time, velocity of B equal to, if you are solving these two, velocity of B equal to VA into sine 36.89 divided by sine 83.11. VA is 3.77. So you will be getting velocity of piston as 2.28 meter per second. Now, velocity of connecting rod BA. Solving these two also, you can solve these two also. Anyway, velocity of BA equal to VA into sine 60 divided by sine 83.11. You will be getting it as 3.29 meter per second. We have been also asked to find the angular velocity of connecting rod. So linear velocity of connecting rod and angular velocity of connecting rod relation is VBA equal to BA into omega, V equal to R omega. So omega BA equal to BA, velocity of BA divided by BA. All these values are known to you. Just substitute over here. You will be getting the angular velocity as 6.58 radians per second. So this is all about general plane motion. This is a very important topic. So understand the concepts clearly. Refer the previous part as well as this part. You can expect any of the questions from these two parts. So there may be doubts related to this because it is a new portion to you. So there may be doubts and there should be doubts. Feel free to ask the doubts through the comment box. Thank you.